Greetings, programs and cocoa nuts the world over. I am the original gamer, Stevie Stroh. And we're back for another chapter in Programming in Basic on the color computer. And we are now on chapter 17, which is called Minding Your P Modes. So now we're going to officially learn about the various P modes, what they are, and what they can do for us. Or more importantly, what can we make them do for us, right? So let's jump in. And let's start to read what chapter 17 has to offer for us. So, minding your P mode, what lets you produce exciting graphics is the massive size of graphics memory. To get a perspective on this, contrast graphics and text memory. Text memory has 512 memory locations. Graphics memory has up to 12,288. So what they're saying here is that your text screen is half of 1K. Now bear in mind, a kilobyte is 1,024 bytes, and our color computer came in a couple different flavors. The first color computer had 4K. Then we upgraded to 16K. Later on, there were 32K upgrades for the Color Computer 1. By the time Color Computer 2 came out, there were 64K CoCo. There was a white CoCo 1 that was 64K, and then there was eventually 64K CoCo 2s. When the CoCo 3 came out, the stock version had 128K, and then you could get it upgraded or buy a version that was 512K. Where am I going with all this? Your text screen, this green screen that we're looking at right now, has 512 bytes or 512 characters of information, which is 1/2 of a kilobyte or 1/2 of a K. But our graphics modes can take up to 12K, which means they are 24 times larger amount of memory than the text screen, right? Because 1 byte of information is a single character on our text screen, but 1 byte of information on our graphic screen is usually only a handful of dots that take up less than 1 line of this text character. So it takes a lot more memory to make graphics. So that's what they're trying to explain to us right now. So it says you can use the power of graphics memory in 3 ways. You can produce graphics with very high resolution, meaning fine detail. You can produce graphics with many colors, and you can produce fast-changing animated graphics by retaining many graphic screens in memory at once. How much can you use each of these features depends on how you set graphics memory. The more you use of one feature, such as retaining many screens of memory, the less you can use for other features, such as high resolution and colors. So the command we're going to learn is called PMODE, which sets the page mode. Okay, PMODE, the unknown statement in the lines program, is what sets the feature you want to use. PMODE lets you set 5 modes shown in this table here. Each mode, of course, has its own trade-off of features. So if we go to PMODE 4, and let's see, and this is as big as I can get this book right now, right? So PMODE 4 has a high resolution of 2 colors, and there are 2 screens in PMODE 4. PMODE 3 is a medium resolution, which has 4 colors, and there are 2 screens of that. PMODE 2 is a medium resolution of 2 colors, and so since there's less color, we can actually have 4 screens of PMODE 2. So PMODE 2 and 3 are basically the same resolution. They are medium resolution, but there is a 2-color mode, which is black and white, and then there's a 4-color mode. And then we go to PMODE 0 and 1, which is our low resolution. If we go to PMODE 0, which is 2 colors, we can actually have 8 screens of information. If we go to PMODE 1, which is low resolution with 4 colors, we can have 4 screens of information. So a screen is like a page, and so there's only one page of graphics you can look at But in your software and in your program, you can switch to different pages and you can do things and draw graphics on that screen and manipulate that screen and do things off screen that nobody will see. And then you can either switch to that screen and make it visible when you're ready to show it, or you can do a command that's called pcopy and copy that page, the background page to the foreground page. And that's what I used to do a lot with games, was I did a lot of things in the background. I manipulated my foreground characters on the background. I copied the superimposed composited image that you only saw when the work was done. And then behind the scenes, I had to then clean up and restore the background and do all that kind of stuff. So page flipping, I believe they use a term too called double buffering, when you do things behind the scene on one page and then copy it to the visible page. When you do double buffering, you eliminate the flickering, because usually when you have to move a foreground object against the background, you have to take a picture of what was behind it. You have to then superimpose an image, and then when you're done and you move it, you've got to put the background back where it was. And so as you're doing that, you're getting flicker. So some of the CoCo games, even in assembly language, you'll notice some flickering on some of the objects, some of the characters on the screen, whereas other ones, things look very smooth. And that technique is, I believe they call that technique double buffering, but it's using different pages of memory, right? So we got basically, we've got low resolution, we've got medium resolution, and then we've got high resolution. High resolution technically only supports two colors, black and white, or if you change the screen mode, black and green. What we were fortunate enough to have on American televisions that use a standard called NTSC. Yeah, because the funny name for that is never the same color. It stands for something else, but yeah, NTSC, never the same color. So American televisions that use NTSC, that black and white PMODE 4 screen, we found out that we were able to get red and blue colors through a process known as artifacting, where they kind of look like different colors, and so that was exploited in a lot of games. So these are our PMODEs. We have PMODE 0 and 1, same resolution, very low. You either have 2 or 4 color options. PMODE 2 and 3, medium resolution, you have a 2 or 4 color option, and then you have PMODE 4, which technically only supports 2 colors, but that is your high resolution screen. All right, so now it says, let's go to the lines program in mode 4. It says, bring back lines and see what it looks like in a different mode. Now, here's the problem. Never once has this book asked us to save our program or told us how to save the program, because technically the only thing that this book is going to teach you how to save to later on is saving to cassette. It's not going to teach you how to save the disk, because that's a whole separate book that's called Disk Extended Color Basics. So when it says bring back the lines, it's basically meaning type this crap in again. But luckily for me, I set this thing up with a virtual floppy, and I think I called that one X. So if I load the X program and I list it, here it is, PMODE 1,1, PCLS, screen 1,1. There's our 2 lines, and 40 goes to itself. Now it says, instead of 1,1, change line 5 to say PMODE 4,1. And then run the program. You should spot 2 feature changes right away. The color changes because you shifted to a 4 color. You shifted from a 2 color to a 4 color mode. The lines are much finer because they're in high resolution. Yes. Now, because this is in VCC, VCC is trying to emulate artifacting. So you can kind of see the red and blue staircases here. If you press F6, F6 turns off artifacting, and now you're going to see that it's just black and white. And you can see here that the lines look better. They look more less jaggedy, right? They look a little bit smoother, because the smaller the pixel, the finer the point, the smoother everything looks. So there we have it. The colors are much finer because they're in high resolution. So on VCC, function key 6 will toggle the artifacting. And the problem with VCC artifacting is that the red and blues that they show are not how they looked on the original television, because this blue is like a navy blue, and on the CoCo it was almost like a very soft pastel, kind of a sky blue. And this red here is a very hard red, and the red was a softer red. It was almost like an orange color. So it was almost like you had black and white and orange and sky blue. where the colors have, as they appeared on televisions. So we'll leave this black and white for right now. So it's basically showing us if we change that program and we change line 5 to switch from PMODE 1 to PMODE 4, we're noticing that we're in a higher resolution, and we're noticing now that we're only in 2 colors. We're in black and white. And now we're going to learn about colors a la mode. Ho, 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 very punny. A 2-color mode, just like a 4-color mode, has 2 color sets. You saw one of the 2 color sets, black and buff. And let's face it, it's frickin' white. Why they called it buff, no frickin' idea. It's black and white. When you ran the lines program in mode 4, to see the lines in the other 2 colors, black and green, make this change screen 1, 1 to screen 1, 0. So over here on line 20, it's actually easier for me to retype it than it is to edit it. Screen, if I could spell right, SCREEN 1, 0. Now when I run this, now you see the green in black. So by changing the screen modes between 0 and 1, 0, regardless if you're in a black and white mode or in a color mode, just think about it this way. 0's a lower number, so you're going to have the lower numbered colors, which just coincidentally all happen to be more of the duller colors, like the mute green and the dark red and the dark blue, and then yellow was kind of the brightest color in that 4 colors. So I always think of screen mode 0 as dull colors, screen mode 1 as bright colors, because in screen mode 1 the green becomes white, which is obviously brighter, and in the graphics mode, when you go to screen mode 1, the background is white, which is obviously bright. And then you also have these other colors like the orange and the teal and the magenta. So you've got like these very bright purple, greens, and oranges that are usually not very pleasing to the eye. But so that's how I've always remembered that, is that low is dull, high is bright, and if that makes any sense at all. So now it's basically saying, you know, you can change it. And then here's a little table that shows you this. So if you're in a 2-color mode, if you're on screen 1, 0, you're going to get black and green, black being the background, green being the foreground. If you're in screen 1, 1, you're going to get black and buff, black being the background, white being the foreground. If you're in a 4-color mode on screen 1, 0, you're going to get green, yellow, blue, and red. And if you're in screen 1, 1 in a 4-color mode, you get buff, white, cyan, magenta, orange. Now it says here, lines through thick and thin. Notice that when we ran lines in the high resolution PMODE 4, you didn't have to change any dot positions. And so Color Basic uses the same resolution grid no matter what resolution you're in. And this is kind of tricky. So basically in a high resolution screen, you're seeing everything. Medium resolution is actually, so in a high resolution screen, you've got 256 across by 192 down. Medium resolution is actually half of this screen. So instead of it being 256 wide, it's only 128 wide. But what it does then is it then stretches out the pixels, because the pixels are twice as wide. So in medium resolution, it's half the screen stretched out. So technically the resolution is from 0 to 127. But rather than having to figure out all these relative resolutions in your different modes, and the low resolution mode was even lower than that. That was 90, what's freaking half of 128? I don't know, but it became like 128 by 96. So then it became half, it became basically a quarter of the screen. So the low resolution is about a quarter of the screen. And so then they stretch it wide and stretch it tall to make it fit, so you get really fat pixels. But rather than having to address each mode by these different relative resolutions, where low resolution is from 0 to 128 and Y is from 0 to 96, and then medium is 0 to 128, Y is 0 to 191, and then high is this, they've kind of let you use the same relative position of pixels on any resolution mode, and Basic just kind of figures it out and does it for you. So it allows you to write the same program and then change the resolutions, and things should relatively show up in the same positions as they did, but they're going to look fatter and blockier and jaggier depending on those resolutions. So notice that when you ran the lines program, you didn't have to change the dot positions. Color Basic uses the same 256 by 192 screen grid, no matter what the resolution is. For example, in 128 by 96 is always the center of the screen, no matter what resolution you're using. And 00 is on the top. Yeah, so 128 over and 96 down. All right, so this is 128 over. This is 96 down, which is half of 192. So that's always going to be dead center in low, medium, or high resolution. And 0, 0 is the top left, which is right here. And 256, 191 is the bottom right, which is over there. So you can use the same resolution statements and commands, and you can use the same grid mapping system and position mentality on any resolution. So thus a diagonal line in low resolution looks more like a stair step than one drawn in a higher resolution, right? So yeah, low resolution is basically double wide, double tall pixels, right? So now here is the size of the dots in the different resolutions. So in high resolution, the dot is 1 pixel. You have 256 by 192. In medium resolution, the dot is actually 2 dots wide, and why they're showing them on top of each other versus side by side is an anomaly, because it's really 2 pixels wide. And then when you're in low resolution, the resolution is 128 by 96, and so this is an actual 4 times difference in resolution. So now it says here's a program that shows a box cycle through each mode. Notice that with each mode, the box's lines go from thick to thin, and its colors go from 2 to 4 colors. So I guess we're going to type in a new program right now. So we're going to do new. So 5 for mode equals 0 to 4. Now realize this, even though it's using a variable called mode that is actually 4 letters or 4 characters wide, Basic on the CoCo only recognized up to 2 letters for a variable. So really the variable is MO. Now 10, PMODE mode, 1. This is where I wasn't sure about the PMODE command, and I'm thinking now the 1 is what page you want to be on, since there's different pages for your different modes. 20, PCLS. 30, screen 1, 1. Okay. 40, line 75, 50 through 125, 100, pset, B for box. 50 is going to pause for y equals 0 to 500, colon, next y. 60, next mode. 70, go to 5 and start over again. So let's see syntax error in 30. I guess I got to spell screen properly with 2 E's. Screen 1, 1. All right. Here's our box. And as we're going through the modes, you can see that the pixels look different, right? So you can see the lines getting thinner in some cases as we go higher through the modes, right? That's the highest mode there. So that's PMODE 01, PMODE 2, 3, PMODE 4, PMODE 0, PMODE 1, PMODE 2, PMODE 3, PMODE 4, right? So it's cycling through all of this. So that's kind of cool. So let's break out of that. So real quick, I'm going to do a shameful plug, and I'm going to throw up a commercial for you right now. If you're a CoCo nut, like I'm a CoCo nut, you can get custom t-shirts that have CoCo on them, and you can get coffee mugs. You know, why not drink your hot cocoa from a CoCo mug? You know, so let me just do a quick shameful plug and mention the fact that we've got CoCo merchandise on my website. So take a look at this for just a second here, boys and girls.
Atari, Sega, and Yu-Gi-Oh! Original gamer gave up a normal life. Stevie Strode. Why'd you interrupt me, Stagger? I'm just playing Streets of Rage 2. What kind of business is this?
This is some off business.
Castlevania CD show. Atari, Sega, and 3DO. Original gamers, gave up a normal life. Stevie Stroh.
So as you can see there, we got all kinds of cool CoCo designs. Those color computer designs were drawn by Instagram artist Joel M. Adams. Joel Adams happens to be the son of Rick Adams, who created Temple of Rom and Shanghai, two great cartridge games released for the Tandy Color Computer 1, 2, and 3. And Joel Adams does really cool drawings on Instagram, and Joel Adams has drawn a lot of cool retro designs that we've set up on a swag shop. 8bit256.com will take you to my website, which has got my links to merchandise. You can also grab a copy of a DVD. Nick Marentes has agreed to allow us to use the Popstar Pilot artwork on a t-shirt and coffee mug as well, so you can grab a copy of that too. The Popstar Pilot, one of the newest, latest, greatest games for the CoCo 3. All right, so that is we just went through our P modes, right? So hopefully the next thing it's going to explain to us is when we do P mode, like when I list this program out here, let me click back on my keyboard. When I list the program out here right now, so it's saying P mode mode comma 1. I'm pretty sure that comma is telling us what page to go to. So let's confirm that as we go further through the chapter here. So it says this is PMODE's format. The next chapter shows you how to use the second parameter, the start page. I just found a typo in the book. How to use. All right. So I found two glitches. Well, number one, they're showing the pixels as being double tall, and they're not. They're double wide. And I've just found use in here. Hello, people. Excuse me. All right. So here's the command here. It's the format for the PMODE command is PMODE mode comma start page. Sets the current graphics screens in graphics memory. So mode specifies the features you want to use in graphics memory. If you omit mode, the computer uses the last mode, or if none, it defaults to mode 2. Start page specifies which page in graphics memory to start a graphics screen. If you omit the start page, the computer uses the last start page, or if none, it uses page 1. Therefore, if you omit PMODE, the computer will use PMODE 2, 1. So again, how many pages do we have? Those pages are listed here. If I do PMODE 0, I can do PMODE 0, 1, 2, 3, 4, 5, 6, 7, or 8. So I've got 8 different PMODE pages. If I do PMODE 1, I've got 4 pages. So I can do PMODE 1, 1, 2, 3, 4. If I do PMODE 2, I've got 4 pages. So I can do PMODE 2, 1, 2, 3, 4. If I do PMODE 3, I've only got 2 pages, so then it becomes PMODE 3, 1 or PMODE 3, 2 for those 2 pages. If I do PMODE 4, I've only got 2 pages, so PMODE 4, 1 is page 1, PMODE 4, 2 is page 2. So there you have it, boys and girls, ladies and gentlemen, ladies and germs. So the takeaways from this, the concepts that we learn here today are the command PMODE and what it does. It sets a mode. Each mode has a predetermined resolution, meaning number of pixels, size of pixels. Each mode has a predetermined set of colors. It's either a 2-color mode or a 4-color mode. And then each mode, depending on the resolution, the lower resolution modes have more pages because it's really, PMODE 0 is like a quarter of the PMODE 4 screen. So there's 4 times as many times you can use that. Whereas PMODE 4 is the highest one, and it's taking up the most memory, so you can only have 2 pages. At the end of the day, the amount of video memory we have is finite. The amount of video memory we have on a color computer 1 and 2 is basically 12K. And so 6K is one screen, 6K is the other screen. And so you can divide that 12K into smaller pages. Or if you have a big page, you can only have 2 of them. And the thing is this, is that the reason why PMODE 4 has half the colors is because there's more dots. And it just works out to how information translates into binary and translates into bits, right? So 1 bit is 8 bytes. And if I'm in black and white, each bit represents 1 pixel, and so I can have these pixels on or off. So with 1 byte of information, I can have 8 pixels that are on or off. The minute you introduce color, you now need more bits to equal 1 pixel. So 4 colors now needs 2 bits per pixel. And so now you've got half the number of pixels that squeeze into the same amount of memory. So it's just basic binary, which is kind of an oxymoron if you don't understand that. So maybe we should do some type of, that might be a cool little project, is to write a program that converts binary to decimal, because I have to do this when I teach my network engineering classes. So that might be kind of a cool little project. I would think it's interesting. Probably nobody else would. But yeah, so we've just finished chapter 17, people. P mode, different modes, different colors, different pages. It is good stuff. We are going to use this as we make our games. So I hope you enjoyed chapter 17, all about the P mode, and we'll be back for another video. So keep on programming your CoCo. Make sure you program responsibly. And I got a question for you.
Hey, you got your CoCo 3
Well,
yet?
my soundboard's not working. It always does this. Or maybe it is and I have my volume turned off on my headset. So hold on, let's try this again. Let's try this. I gotta turn up my volume here.
Hey, you got your CoCo 3 yet?
Have you got your CoCo 3 yet? I hope you have. I hope you've enjoyed this video. And we are going to end things now, people.
End of line.
Couldn't resist the sound drops. All right. Take care, everybody.